As one of the lesser known, but nonetheless vital precious metals, platinum has a long history of being used for jewelry and ornamentation, reaching back to the ancient Egyptian Empire, having been discovered on a coffin unearthed in Thebes, estimated to be from the 7th century BC. Platinum is a metal that represents power, prestige, and a sense of great accomplishment. It has come to symbolize a high level of status in society, as evidenced by top-tier credit cards and membership programs using its name. But platinum is so much more than just a status symbol. Modern-day uses of platinum include being a key element in catalytic converters for vehicles, as it converts car exhaust gases into less harmful substances, as a catalyst in the chemical industry, and even in the creation of life-saving anti-cancer drugs. But that's just scratching the surface. On today's episode, we explore this exclusive metal that befuddled miners and scientists alike when it was first discovered. Dubbed platina, or little silver by the Spanish conquistadors, the truth is, it's so much more than meets the eye. Time to dig into platinum on Commodity Culture. Platinum is a gray-white precious metal, and one of a group of 6 elements known as the platinum group metals. The other metals in the group are iridium, osmium, palladium, rhodium, and ruthenium. Platinum is the most common of the group and sees the most use. Platinum's atomic number is 78. It has an atomic mass of 195 units, a melting point of 1,768 degrees Celsius, and is resistant to corrosion, stable at high temperatures, and has stable electrical properties. The name platinum comes from the Spanish word platina, basically translating to little silver. This somewhat derogatory word was coined by Spanish conquistadors in the 16th century, as they had no idea of platinum's uses or true value, and considered it an annoyance that interfered with their attempts to mine gold. In those times, it was widely believed that platina was young gold, and that given time, it would turn yellow as it matured, but until then, better to toss it aside and get back to mining for the real thing. Platinum is rarely found on its own. It is often deposited alongside gold, copper, iron, nickel, and of course, the other platinum group metals. When discovered, platinum can be quite inconspicuous at first glance, with nuggets having a dull gray or black hue. One thing that can help identify it is its incredible heft when held, and if iron is also present in the alloy, it will be slightly magnetic. Some of the first known platinum jewelry was crafted by the ancient indigenous peoples of Ecuador, with estimates placing their culture several centuries before the Spanish conquest of South America in 1492. It was particularly in the province of Esmeraldas where some of the most striking pieces were found, leading anthropologist William Farabee to declare, "The native Indian workers of Esmeraldas were metallurgists of marked ability. They were the only people who manufactured platinum jewelry." Considering platinum is far more difficult to forge and manipulate than, say, gold or silver, the method these ancient peoples used to work such a problematic metal was nothing short of incredible and a testament to their dedication to their craft. Platinum fragments were coated with gold dust, then heated by blowpipe on pieces of wood charcoal. The molten gold then caused the platinum to sinter, meaning coalesce into a porous mass through heating, which then allowed it to be forged. Being the rarest of all the precious metals, along with its incredible strength as the hardest among them, has led platinum to being one of the preferred forms of jewelry throughout the ages. In addition, it is highly resistant to scratches and other blemishes and does not wear away easily. Platinum, along with the other platinum group metals, has strong catalytic properties, meaning it can accelerate or trigger a chemical process without becoming permanently changed or consumed. For this reason, it is employed widely in the manufacturing of catalytic converters for use in exhaust systems in internal combustion vehicles. Platinum present in exhaust systems helps curb vehicle pollution and contributes to enhanced air quality. Catalytic converters represent a whopping 50% of platinum demand each year. Due to its high melting point, platinum is indispensable in chemical laboratories for electrodes and for crucibles and dishes in which materials can be heated to high temperatures. In addition, platinum is used in the chemicals industry as a catalyst to produce nitric acid, benzene, and silicone. It is also used as a catalyst to improve the efficiency of fuel cells and for electrical contacts and sparking points, as it resists both the high temperatures and chemical attack of electric arcs. Platinum finds use in the electronics sector in the manufacturing of computer hard disks and thermocouples, is used to make optical fibers and LCD screens, turbine blades, spark plugs, pacemakers, and like other precious metals, is used widely in dentistry. Crowns, bridges, pins, and other dental equipment, as well as fillings, all employ platinum as a key component. But one of its most impactful uses to humanity is in the creation of chemotherapy drugs used to treat cancer, of which platinum compounds are an important building block. I'm willing to bet you didn't think platinum was such an essential element to our day-to-day lives, but the truth is, it's a metal that is as practical as it is prestigious. Next up, let's explore the mining methods used to extract platinum from the earth. Being one of the rarest metals on Earth, platinum is almost never found on its own, but is generally found alongside platinum group metals, nickel, iron, gold, and other metals. Although pure platinum deposits have been discovered, they are the exception rather than the rule. One of the earliest platinum mining methods is placer mining. Like gold, platinum particles can accumulate in alluvial sands in rivers and streams. Placer deposits are concentrated sand and gravel beds in streams and rivers created when old rock is eroded from its source and further ground into pieces as it is washed away by the water. Most of the world's placer platinum is found in Russia, and back in the 19th century, alluvial deposits located in the Ural Mountains were heavily mined by both small-scale family operations and more official mining operations. Placer mining for platinum was also common in South America, especially in the Rio de la Plata, or the River of Silver, located between Argentina and Uruguay. Placer mining involves using dredges to scoop platinum-bearing sand or gravel from riverbeds and washing it until platinum grains or nuggets are captured and separated from the surrounding material. In today's world, the vast majority of platinum deposits are located underground, and this is mined very similarly to gold, silver, and other underground metal deposits, namely with strategically placed explosives. Miners drill holes into the mine walls and pack explosives into them before detonating the rock, blasting it into small pieces and hauling it up to the surface to be loaded onto trucks, which then take it to a facility to be processed. Most platinum mining in the modern era is done in South Africa, which accounts for a whopping 80% of world platinum production. The story of the man who first identified platinum and began to make it known to the greater world is no less fantastic than the element itself, involving an adventure across continents, a capture and daring escape on the high seas, and a scientific discovery that would begin platinum's journey to becoming the dynamic metal we know it as today. Antonio de Ulloa of Spain was only 19 years of age when he was promoted to the rank of frigate lieutenant and sent on what would be a life-altering expedition to Quito in Ecuador, led by French geographers Charles-Marie de la Condamine and Pierre Bouguer. Antonio departed Spain in May of 1735, not knowing he wouldn't see his motherland again for more than a decade. The mission was a monumental one, to help determine whether the Earth was flat, as was popularly believed throughout most of human history up to that point, or whether it was a sphere, as suggested by Sir Isaac Newton. To this end, it was necessary to measure the length of a degree of longitude at the equator, of which Quito was the closest city, and again it's somewhere as near as possible to one of the poles. An expedition to the far north of Sweden was also dispatched for this purpose, but our story shall leave that journey to the pages of history. As Antonio accompanied the geographers in Ecuador, their task proved epic indeed, and with great struggle, they finally completed their work around 1745. Over the course of this decade, Antonio had plenty of time to explore the territory and the people there, recording his more interesting observations in various papers he carried with him. As the expedition finally departed back to Spain, their mission accomplished, Antonio must have been filled with strong emotions, as he was at long last headed home. Fate, however, had other plans in store for him. As they made their way, sailing around Cape Horn, they were chased down north of the Azores by an English privateer and their ship was captured. However, they managed an escape, and as luck seemed to be on their side, they evaded their captors and seemed to leave danger behind. But God seemed intent to test their wills, and as they reached Louisbourg in Nova Scotia, their vessel was once again captured, this time by a British naval vessel, and escape was out of the question. Antonio and his companions were taken to London and imprisoned, while the Admiralty confiscated nearly a decade's worth of notes from Antonio's time spent in Ecuador. Things looked grim for our frigate lieutenant as he sat in a cell awaiting his fate. But when God closes a door, he is known to open a window, and good fortune came in the form of the president of the Royal Society, Martin Folkes, who came to know Antonio and his story and befriended him. The Royal Society were a group of natural philosophers and physicians, and not only did Martin free Antonio from his chains, he got all his papers returned to him and even made him a Fellow of the Royal Society in 1746. He was then allowed to return to Spain. Finally back after his long mission, he set to work compiling an account of his adventures, which he published in 1748, first in Spanish and then had it translated into several other languages. For the purposes of our subject today, one passage in particular stands out. In the district of Choco are many mines of lavadero, or wash gold. Several of the mines have been abandoned on account of the platina, a substance of such resistance that when struck on an anvil of steel, it is not easy to be separated, nor is it calcinable, so that the metal enclosed within this obdurate body could only be extracted with infinite labor and charge. Shortly after releasing his book, Antonio was tasked with a new mission by the King of Spain himself, King Ferdinand VI, to travel throughout Europe and study scientific developments across the continent. His travels brought him to Sweden in the autumn of 1751, and he was welcomed with open arms by Swedish scientists. Shortly after his arrival, he was duly elected to the Royal Swedish Academy of Sciences in October of the same year. During his time there, he met with mathematician and chemist H.T. Scheffer. Scheffer was a former mine and metalworks manager as well as an assayer at the Mint, and so had quite a vested interest in metals. There is no official record of what exactly was said in that meeting, but shortly thereafter, in November of 1751, Scheffer produced a paper titled The White Gold, or Seventh Metal, called in Spain Platina del Pinto, Little Silver of Pinto, its nature described, and submitted it to the Academy. Scheffer was already familiar with platinum before encountering Antonio, as he himself had received samples of it just a year earlier in 1750 from the West Indies, but his time with Antonio undoubtedly influenced his writing. In the paper, he came to the following conclusions about platinum: that this is a metal hard but malleable, but of the hardness of malleable iron; that it is a precious metal of durability, like gold and silver; that it is not any of the 6 old metals, since first, it is wholly and entirely a precious metal, containing nothing of copper, tin, lead, or iron, because it allows nothing to be taken from it. It is not silver, nor is it gold, but it is a 7th metal among those which are known up till now in all lands. In addition, he recommended a potential practical application for platinum when he wrote, "This metal is the most suitable of all to make telescope mirrors, because it resists as well as gold the vapors of the air. It is very heavy, very dense, colorless, and much heavier than ordinary gold, which is rendered unsuitable for this particular use by lacking these 2 latter properties." Although attempts were made in the years that followed, platinum never found its place in telescopes of the era. Although Scheffer would be delighted to know, the metal did eventually find use in the construction of X-ray telescopes centuries later. Nonetheless, his paper sparked the imaginations of scientists across the world, and a flurry of research into platinum began, leading it to be established as the multifaceted metal that we know in the modern era. Although the recent trend towards electrifying vehicles seemingly puts platinum's use in traditional gasoline-powered catalytic converters at risk, we need to step back and look at the bigger picture. In the coming years, auto catalyst demand for platinum is actually likely to rise, as recent legislation to curb pollution from gasoline and diesel engines is boosting the demand for cleaner emissions, which is platinum's forte. Either way, platinum will have a role to play in a carbon-neutral future, as it is needed for hydrogen-powered fuel cell electric vehicles. These use a propulsion system similar to that of electric vehicles, where energy stored as hydrogen is converted to electricity by the fuel cell, and these vehicles are already becoming available in California and a few other places. Platinum is also playing a role in the greater energy economy, as platinum-based fuel cells are a cost-effective, clean, and reliable off-grid power source that is currently seeing use in some remote areas, such as rural South Africa. These fuel cells can help provide greater energy access to communities who might not normally be able to get a steady source of electricity. This includes electricity for schools, improving the quality of education, and provides the ability to pump water for irrigation, facilitating agriculture. Its other myriad of uses also aren't going away, and for this reason, platinum will remain an essential metal to our modern civilization for as long as we can extract it from the earth. Commodity Culture is a series that covers the history and culture surrounding commodities and natural resources. If you enjoyed this episode and want to see more, please subscribe and hit the bell notification to ensure you are always alerted of the latest episodes.